Today we shall study pair of straight lines. Pair of straight lines. We already know that linear equation ax plus by plus c equal to 0. This represents straight lines. Suppose we have two such equations. One is this and another is a dash x plus b dash y plus c dash equal to 0. And if we multiply these two equations, we get a dash x square plus b dash y square plus a dash b plus a b dash xy plus a dash c plus a c dash x plus b dash c plus b c dash y plus c dash equal to 0. So if I multiply these two linear equations, I get a degree 2 equation, and notice that any point satisfying either this or this equation will definitely satisfy this equation, and conversely if I take any point satisfying this equation will certainly satisfy one of these two equations. So it means this second degree equation represents a pair of straight lines, because this equation I have obtained from the multiplication of two known straight lines. Now the question arises, if we have a general equation of degree 2, when does this second degree equation represent a pair of straight lines? We already know that in general it is not true that any second degree equation represents a straight line. For example, we know x square plus y square equal to 4. This is a second degree equation in x and y, but it represents a circle. It doesn't represent a pair of straight lines. So we first do a little simple case. The simpler case is if the degree 2 equation is a homogeneous equation in x and y, then find the relation among a, b, c, d, e, and after having done that, we shall go to the general case. So let's see first the particular case when the degree 2 equation is a homogeneous in x and y. Square plus by square plus c xy equal to 0 be a second degree homogeneous equation in x and y. So aim is to find the relation between a, b and c such that this equation may represent a pair of straight lines. So looking at this equation, we can easily see that this equation can be considered as a quadratic equation in x or quadratic equation in y. Write this as by square plus cxy plus ax square is equal to 0. So the roots of this equation are y is equal to minus c plus square root of c square minus 4ab over 2bx, and another is y is equal to minus c minus square root of c square minus 4ab over 2b. So this equation gives me these two equations which are linear in x and y. Now the question is whether these two represent straight lines. The answer can be yes if this number inside the square root is either 0 or positive. So if this number is negative, we can't find the square root. It means it will not represent a straight line. So if this equation has to represent a straight line, the c square must be greater than or equal to 4ab, or c must be greater than or equal to 2 root ab. So now we shall move to the general case when we have a second degree equation in x and y. So what is the relation among the coefficients such that the second degree equation may represent a pair of straight lines?